Welcome to the Explainer. Today, we're going to try and crack open that black box of AI. Our goal is to really build a solid mental model for how this pretty transformative technology actually works. Okay, so let's just jump right into it. I mean, we've all played around with tools like ChatGPT, right? Or seen those incredible AI-generated images. But what's really going on under the hood when you type something in? What is it that you're actually talking to? This slide really gets to the heart of it. For the longest time, machines were basically just really good at following orders. We gave them a set of rules, and they followed them perfectly. But modern AI, it's a whole different ballgame. Instead of giving it a rigid instruction manual, we train it to learn from massive amounts of data. It's much more like teaching than it is programming. So that brings us to our first big question. We're going to define what we even mean by a digital brain. Because, spoiler alert, it's not some kind of magic conscious entity. It's a computational model, and it's built on some very specific principles. So, deep down, at the very core of most AI today, you've got this thing called a neural network. The best way to think about it is like a huge, complex system with millions, sometimes billions, of tiny digital knobs and dials. Each one is a parameter that gets tweaked and tuned over and over and over as the AI sifts through all that data it's learning from. And all that complexity, well, that's what leads to this black box problem everyone talks about. The AI takes your input, let's say a question, and it gives you an output, an answer. But the process in between, it's this dizzying web of calculations based on how all those millions of knobs and dials are set. And what's wild is that sometimes not even the people who built it can tell you exactly how it got from point A to point B. Okay, so how in the world does this digital brain even learn how to set all those dials in the first place? Well, the process is called machine learning, and it really comes in three main flavors.
So there are three main ways we train these things. First up is supervised learning. This is where we basically give the AI an answer key. We feed it millions of examples that are already labeled, tons of pictures tagged cat or dog, and it learns to tell the difference. Then you've got unsupervised learning. Here, we just dump a giant, messy pile of data on it and say, okay, figure it out. It has to find the patterns and group similar things all on its own. And finally, there's reinforcement learning. This is all about trial and error. The AI tries something and we give it feedback, like a coach saying, good job, or try again. This is a huge part of how models like ChatGPT actually get better and more helpful over time. But here's the thing, no matter which of these methods you use, there is one golden rule that you absolutely cannot forget. The quality of an AI's output is 100% dependent on the quality of the data it's trained on. Bad data, biased data, it will always lead to bad and biased results. All right, so we know how it learns, but how does it actually use that knowledge to create stuff? Like the text you get from a chatbot or one of those wild digital images. See, when an AI model writes something, it's not thinking about what it wants to say. Not at all. It's really just a super-powered prediction engine playing this incredible high-stakes game of what comes next, one tiny piece at a time. At every single step, it looks at the text it's already written and calculates the odds for the very next token. Now, a token can be a whole word like apple or just a piece of a word like ing, or even just a comma. So it looks at the cat set on the, and it says, okay, based on everything I've ever read, the most likely thing to come next is Matt. It sticks that on the end, and then it does the whole thing all over again for the next token. It's just building a response, piece by tiny predictive piece to create sentences that are statistically likely. Now, what's really cool is that a similar idea is at play for creating images, but it's kind of like it works in reverse. It's not about predicting what's next, it's more like revealing something that's hidden. Yeah, it's called a diffusion process. The AI literally starts with a screen full of random static, just total noise, right? And then, using your text prompt as a guide, it starts tweaking the pixels, bit by bit, slowly removing the noise until a clear picture emerges. It's almost exactly like a sculptor chipping away at a block of marble to reveal the statue hidden inside. But, and this is a huge but, this digital brain is nowhere near perfect. It's got some really deep inherent flaws that come directly from how it's made and what it learns from. And two of the biggest ones are bias and hallucinations. So AI bias, it's what happens when the training data doesn't actually look like the real world. Think about it this way. If an AI was only ever shown photos of penguins, it would probably think all animals are black and white birds that waddle.
It develops this totally skewed worldview because it's only ever seen a tiny biased slice of reality reflecting all the gaps and prejudices from the data we give it. And then there's the other big one, hallucination. This is when the AI just makes stuff up, but says it with total confidence. And it happens because, remember, its only job is to predict the next plausible sounding thing. It's not trying to tell the truth, it's just trying to complete a pattern in a way that sounds right, even if it's completely factually wrong.
And honestly, if you remember one thing from this whole explainer, make it this. It is such a crucial distinction. These models are designed to generate text that makes sense, not to be the ultimate source of truth.
So, where does that leave us? What's the big takeaway here? When you strip away all the hype and the science fiction, what is AI really?
Well, it's definitely not a magical mind. It's not conscious. What it is a statistical mirror, a giant, powerful mirror that reflects the billions of pages of human text and images we fed it. It reflects our knowledge, our creativity, our language, and yeah, all of our flaws and biases too. And that leaves us with one last big question to think about. If these machines really are a mirror, what does the reflection they're showing us right now say about us? Thanks for joining this explainer.